Hi everyone, welcome. The purpose of this video is to talk through the internal assessment in chemistry, give you some tips and tricks, some things to think about, some things you should definitely avoid. So let's jump right in. Let's get started with the research question. What does a research question look like in IB chemistry? In all of your research questions, you should be investigating how does one thing in chemistry affect another thing in chemistry? Another way to say this, how does some independent variable affect some dependent variable in chemistry? So maybe how does the temperature of a reaction affect the rate of a reaction? Or maybe, how does the position of a substituent group affect the boiling point for that particular organic molecule? So you can have an experimental research question, you can have a database-based research question, but all of you should be investigating some variable affecting some other variable. So in this case, you would vary temperature and study the rate. In this case, you would vary the position of the substituent group. You would look up different molecules with different substituent groups. So maybe you're interested in something like pentane, and you throw on an alcohol substituent group to make an alcohol molecule, pentanol, and you vary where that alcohol substituent group is and see how that affects the boiling point. Great. You're changing one thing and measuring how it affects something else. That is the basis for all of your research questions. Your research question might end up phrased slightly differently from this, but it should get at how does one thing affect another. In your research question, you want to avoid using the words suitable or effective. Often students are tempted to say something like, is a high temperature effective for generating a fast reaction? Notice this is not super specific. You don't define what you mean by effective here. So it's really important that you have a really clear research question with something you're investigating and something else that you'll measure. I'm going to pause here for a second. Make sure you stop the video at this point and re-listen to it if anything is unclear. I want you to realize that generating a good research question is generally the hardest part of the IA. If you have a clear research question with a clear independent variable and dependent variable, you're going to be in really good shape. That really leads into the rest of the IA, because with a clear research question, you can get enough data, you can have a solid analysis that relates back to the research question. So this is a really essential key step in the process. All right, let's look at an example. This is the classic IB Chemistry IA. Students love investigating this. Something like independent variable, brand of orange juice. Dependent variable, concentration of vitamin C. We're learning in this unit how to do this procedure called a titration, where you determine the concentration of a solution. This is the classic go-to. Someone doesn't know what to do for an IB, IA. They are going to grab a bunch of orange juices, study the concentration of vitamin C. Let's talk through what the implications are for this study, and then talk about what's good about this study and what you want to avoid. All right, so my IV, brand of orange juice, my dependent variable, concentration of vitamin C. That leads to that research question we talked about already. How does IV affect DV? How does the brand affect the concentration? This is a clear research question. I'm going to study the effect, the really, really specific effect of the brand on the concentration. All right, another thing I would have to consider, of course, are my control variables. In chemistry, temperature is an essential control variable, and we control temperature always with a digital thermometer. That is not how you spell thermometer. Thermometer. It is not sufficient to just say, oh, I did my experiment in the same room, or I had a fan on and the fan was maintaining the temperature. In all of your IAs, if you are doing an experiment, you should be controlling the temperature, measuring the temperature, making sure it's not changing. The same is true for the humidity of the room. Even the air pressure of the room that day, those are all things you would want to report in your data. Super important control variables in chemistry. You would also, of course, control your entire titration setup. So you would use the same glassware throughout. You would titrate against the same solution in titration. I know that might not make sense quite yet, but we're working through stoichiometry, so you'll soon understand very well how to do a titration experiment. You would use the same volume of orange juice, maybe even the same amount of pulp in the juice. So it's really important that you consider all of the control variables, all of the things that could affect your result, so that in your analysis you can provide really strong evidence that your independent variable was the thing affecting the dependent variable. And hopefully you saw that looking at the rubric, the importance of really, really considering all of the control variables and all of the ways in which the experiment could be impacted. All right, so this would lead you to an analysis like this. You might have your different brands. These are different brands from the United States of orange juice. And this was the experimentally determined vitamin C concentration. Notice they do not have uncertainty in this graph. That would be something you would need. They also then compared what they found against what they saw in the labels of these different brands. So for Del Monte, for example, or Del Monte, I guess in the US, we have these two concentrations. The one they experimentally found was slightly higher than how much vitamin C the label reported. So this would be an appropriate analysis for this type of experiment. All right, what's good about this experiment? Well, there was a really, really clear research question, a really clear IV that affects the DV. It's an independent variable that actually has an effect on the dependent variable. We can clearly define the independent variable, clearly define the dependent variable. It was clear. Hopefully you saw as you were working through grading the example IA that we looked at, the importance of clarity is like can't be overstated, because if you're investigating something that's really, really apparent what you're trying to get at, it's going to lead to a really strong IA because you'll be able to analyze and explain really clearly from there. Again, word of the day, whoops, sorry, I went in the wrong direction. Word of the day is clear. Clear independent variable, clear dependent variable. And there's a direct connection that you can draw between the independent variable and dependent variable. I can pretty clearly say, well, brands might differ in their vitamin C content. That's not really a leap of logic that I'm making. So clear and direct, that is good. I often see students wanting to come up with the most complicated sounding thing that they can think of, and that tends not to score very well because it's hard to structure a really compelling and clear, not to reuse this word, but clear argument if you're trying to make the question complex just for the sake of being complex. So focus on clarity. I love it. Um, what you need to really avoid from this research question is something like a brand comparison. So they were investigating the effect of brand on concentration of vitamin C. Why are brand comparisons not very compelling? Well, it's actually best if your IV is quantitative. So a brand is not quantitative, it is qualitative. I would describe a brand. I would come up with a list of brand names like Del Monte and all the other ones that you saw listed in the table. So it's actually better if your independent variable is quantitative. So you could kick this IA up a notch just by, instead of looking at brand, looking at the effect of temperature on vitamin C concentrations. Sorry, I'll add in this word concentration. So already a stronger IA because your independent variable is quantitative. So you're measuring the same thing, but now you have one brand and you're changing the temperature. It's even better, so it's great if your independent variable is quantitative. It's even better if your independent variable is something that has a range. So something like temperature, where you have endless temperatures that you could study. You would then choose several conditions. So you would choose, maybe you want to study at 10 degrees, at 20 degrees, at 30 degrees, etc. So it's really, really best if you have a quantitative independent variable. So that means that brand comparisons are out because they're not quantitative. Even better if the independent variable comes in some sort of range of numbers. So something like temperature or pH. So something that's not discrete, but we can get kind of endless numbers. And then, of course, from there, you would choose whichever conditions you want to study. Another note that's relevant here is how much data you should be collecting. You should have 5 conditions of your independent variable. So again, if that's temperature, you would choose 5 different temperatures. I've shown 3 here, so maybe you add 2 more. You should have 5 conditions and at least 3 trials each. All right, so you want to avoid brand comparisons. So the example, the classic IBIA of how does brand affect vitamin C? Not the strongest because we don't want to compare brands. Also, just vitamin C titrations are a little bit boring because, as I'm telling you, it is the classic option. So it's really best if you can come up with something a little bit more creative, have a little bit stronger of a personal engagement. Really try to avoid this vitamin C titration if you can because it's just so overdone, unfortunately, in the IA. All right. So again, I encourage you to stop and pause. Make sure you understand everything we've talked about so far. We've talked about research questions, we've talked about variables, and we've talked about things to avoid with the independent variable. All right, let's take a look now at what you might do if you have to do an experiment at home. So yes, you absolutely will be able to check out equipment as appropriate, not something that's super expensive or super dangerous, but pH meters, the Vernier Lab suite, the digital thermometers, stuff like that, totally fine. And then a lot of reagents you can actually find at home. Even something like deionized water is something that you can find and use at home. So you would be surprised at how much can be done at home. Some things to be careful with if you do choose to go the route of planning an experiment at home. One thing that the IB has told us is that they are not allowing students to do anything higher than 50 degrees Celsius at home. So if you're studying the effective temperature, well, 50 degrees is your max for planning an at-home experiment. Be careful that you're keeping the chemistry at the IB level. That was something that the IB called out for the most recent students who did at-home experiments, that students kind of oversimplified some of the chemistry because they were at home. So make sure you're keeping it really appropriate at the level that we're learning in class. Also, not surprisingly, you can't use corrosive or toxic substances, so something like bleach would be out. Also, any organic liquids do not have, you don't have a proper disposal option, so those would be out as well. Sorry. Okay, so you might be thinking, I don't know about this at-home situation, doing an experiment at home, collecting enough information, collecting enough data, getting my IB lab skills to the appropriate level. Maybe I want to do a database or simulation. Great. The IB suggestion there is to let the availability of data or simulations guide your research question. So you might kind of have something in mind, and then you can dig into the resource I posted with a list of simulations and databases and figure out what research questions would actually be available to you. So that is also a really good option. If you're choosing to do a database or simulation, IA, make sure you focus on getting sufficient data. You'll remember from the IA rubric, sufficient data is one of the strands. And the expectation for sufficient data is more than you would have collected experimentally. So remember, experimentally was 5 conditions, 3 trials each. The IB recognizes that it takes more time to get a trial if you're doing it experimentally rather than pulling it off a database. So the expectation, again, is if you're using a database or a simulation, you're getting even more data than you would have done experimentally. One way to do that is to collect the same data for multiple databases, and that can help introduce some uncertainty into a database simulation, which I know you saw the importance of considering uncertainty and precision in your measurements. You saw that in the rubric as well. One really cool thing about a database or simulation IA is there's lots of opportunities to be innovative in methodology. Sometimes there's only so much that we can do in the lab, like there's only so much creativity you can show in design into titration because you have to do the titration and follow the stoichiometry. But with a database and simulation, there's actually some opportunities to be really creative and use the data and present the data in a new way than what it's being shown. That does require that you have a deep conceptual understanding of what's happening in the chemistry that you're describing. All right, so far we've talked about research questions, we've talked about variables, we've talked about things to avoid, and we've talked about some notes for at home versus and how you're going to deal with that. An at-home experiment versus a database simulation. So, a couple final things, and thank you for sticking with this video. I am requiring that you choose an experiment with an at-home component. That could mean that you have a simulation that could be done in person. So you'll do either the simulation or in person, or you just choose to go the database route where you're not worrying about it potentially being done in person. Remember, by May of this year, you will have an introduction, you'll have a research question, you'll have variables. Of course, your introduction involves the personal engagement and background. You'll have your method, and you'll have a blank data table. So you'll be about halfway done with the IA when we leave for this school year. And this will be a key assessment grade. This will be your 7th key assessment grade for the year. When we come back in August of the next school year, that's when we'll actually do the data collection piece. And you'll put everything together for your final internal assessment. All right. Again, I'll leave you with this. Your research question needs to be clear, needs to be measurable. So not just how suitable, how effective, but something that we can measure. Always make sure that you have multiple trials, whether you're looking up the same data in different databases or you're actually performing the same experiment over and over again. That gives your data some validity and allows you to do some statistical analysis. In chemistry, control variables are really important. Temperature is a key one, and you need to think about how you'll control the variables. Make sure you're also considering precision. That was something that IB pointed out, that if you're doing an at-home experiment, your instruments need to be precise enough to get good chemistry data. So that means you're not using a kitchen scale, for example, or a meat thermometer, for example. You do need precise data, and the IB is not being flexible on that, even given the distance learning situation. All right, everyone, thank you for sticking with this video. I hope you'll come back to it and check in as we move through this process to kind of remind yourselves of the things that I'm highlighting is really important here. And good luck. You'll be great.